Hello guys and welcome to the new video. So today we are going to study about this new Kaggle competition. So the name of the competition is Optv Trading at the Close. So this is about a Nasdaq Stock Exchange data. So this the last 10 minutes data has been given to us and we are supposed to predict the closing price of that stocks of that day. So yeah, this is about the competition and now let us check out some of the work done by our. So yeah, as you can see, this is the basic notebook that has been given to us. So this is the data. So let us first start with the notebook. So this is our notebook. So first let us do an ET on the data. So we'll be using pandas profile. So let us first import the pandas profile. So pandas profiling takes a data file. We will also need pandas, but we have already imported pandas here. Now the way to create a profile is by using this. So yeah, we have to first save the data in a data frame. So let us open the data. So this is the train.csv file. Let us import it into a data frame. So we'll do use pandas.csv to save it into the df, and once it's done we will check the df.head to see the basic 5 lines of the data. So yeah, it's taking a bit of time. I think the data is huge. So yeah, so as you can see, this is the data, and we also have some NaN values here. We will have to deal with that. So yeah, let's check the data. So let's check the shape once. That should not take that much time. I think the CPU is full, that's why. So, yeah, 100%. Okay, anyway. So now let us create the report. This will create the pandas profiling report. So while the report is being created, pandas profile. Okay. Pandas profiling report profile report. That should handle it. Okay. So now while this is being processed, let us look at some of the work that has been done. So this is the basic submission demo. So yeah, we were looking at this. So this person named Nolan has done a amazing ATA out of the data. So he has a focus on the missing values. So as you can see, uh, so let us look at the column stock ID, date ID, and seconds in bucket. So these are the unique stock IDs. So there are 200 stocks and 481 date levels in the data. Okay, so for every stock there must be this many data points based on the every column value. So if we check out the values uh, stock columns that the data is less than this much values, we find out that 15 stocks have less than 26,455 data points. And for every day there should be 11,000 data points. So the number of days we have less than 11,000 data points are around 299. Okay, so yeah, this looks like a plot, and These are the number of seconds missing. Okay. So we can conclude 15 stocks have missing data points. For 15 stocks, missing point decrease over time in general. Okay. So what we are gonna do about this 15 stock data point that are missing? So basically, here's first check the null values in each column. So as you can see, these far price and near price values have many null values, so to check on that. But for this imbalance size, this have some common 220 null values. So maybe there might be some correlation on that. And so let us check this missing 220 values. So these are the So now this all these 220 missing values, they all come together. After this analysis, you can find out that. So if we drop them, basically all the features have now zero null features. So now the only thing is left is far price and near price. So we have to check on that null values. So now for far price, you can see that they only start existing after 300 seconds, and for every stock, date has available far price data. Okay. And every stock date has available far price data. So far price data exists for every stock, but the thing is that far price is only existing after 300 seconds. So maybe we have to remove the first 300 seconds of every data point. And for near price, also shows the same pattern. So total number of data before 300 is this much. Missing data points is that much. So let us now look at after 300 data points. You can see there are no null values. Far price is there. Far price is missing values after 300 seconds. So except far price, no values is missing data points after 300 seconds. So maybe the first two things that we can do is remove first 300 and basically we're more focused on the last 300 seconds, right? So if we remove the first 300 seconds also, I don't think that will be an issue, but obviously this comes with experimentation. And the second thing is after 300 seconds there is one variable, that is fair price. So that column needs some analysis. So after 300 seconds we need to look into that. So now this gives us a fair amount of idea about the missing values. And yeah, and this is another example. So yeah, this is another notebook where he has used LGB and regressor. So he has not done any handle the missing values. So he is able to get silver without handling any missing values. So maybe if we handle the missing values, we can get a similar score. So yeah, this is the import, and basically he is doing some feature analysis here. That is not very much clear. You have to look into that. And yeah, after feature analysis, this is the data. And he has used LGBM regressor, and these are the feature importances. And yeah, this is the prediction. And yeah, so this is very basic, very simple prediction. So an optimized model we would have to look into the missing values, handle the missing values properly, then also have to look into the feature analysis that he has done, which engineering that has done. So to do a similar which engineering or to look into it more extensively. And after that, I think we can move on into a model. For choosing a model, I will not choose an LGPM degreaser directly. I hope we use a open search CV type of thing, and maybe you can use PyCaret for that. And yeah, so this is the plan basically. So first you have to remove the first 300 seconds. You can do that, and after the first 300 seconds, you have to handle the fairness. After that is done, you can basically do some feature engineering. After that, you will do some feature engineering, and after that, you can probably use PyCaret for model selection. And yeah, that's it. I will do some assembly using PyCaret only, some hyperparameter tuning, and yeah, that's it. That should solve the problem. Next will be prediction, and again redo a bit. So this is the basic outcome or idea behind it. So now, yeah, it is not completed as data set is used. So yeah, it will take some time. So let us wait till then.